Okay, welcome back once again to all my dear students. Today we are going to discuss a next point, that is types of covalent bond. Before discussing the types of covalent bond, let us revise the topic which we had discussed yesterday. Yesterday we had discussed about the Lewis dot representation, right? Now you all know that what do you understand about the Lewis dot? That certain points will be given, that the central atom, that an atom having a less electronegativity is considered as a central atom, and surrounding to that the more electronegative element will be attached, right? Then we can say that the outermost orbital electron which are taking a part in the formation of bond, that is called bonding electron pair, and not taking a part, then we can say the non-bonding electron pair. That all these things we have discussed yesterday. Now today we are going to discuss the first point, that is the limitation of Lewis representation. So let us see that what are the limitations are there for Lewis structure. First of all, the last point is left, that limitation of Lewis approach. Which are the limitations for the Lewis approach? First one, he says that the shape of molecules cannot be known, right, with the help of Lewis approach. Shape of molecules cannot be known. Understand? Next one, we can also say that just like if we take the BeCl2, the octet of central Be atom is not completed. In BeCl2, the octet of central atom Be is not completed. As for example, just like beryllium is a central atom. See here. Here in the outermost orbit only 2 electrons are there, right? Here chlorine and here also chlorine. So 1, 2, 3, 4, 5, 6, 7. Right? Same way here 1, 2, 3, 4, 5, 6 and 7. See, this is octet state will be completed. Here also octet state will be completed. But here, in between that beryllium, only 4 electrons are there. Then also we can say that BeCl2 is a stable. Even then, this compound is stable. Even then, this compound is what? Stable. Right? Octet state complete nahi hai. Then also we can say that it is a stable. Second example, just like in PCl5. See, phosphorus is the central atom. How many electrons? 1, 2, 3, 4 and 5. Chlorine 1, 2, 3, 4 and 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7. यहाँ पे yes, यहाँ पे 1, 2, 3, 4, 5, 6. यहाँ पे 1, 2, 3, 4, 5, 6. भी देख, यहाँ पे ये जो है ना, ये फॉस्फरस से ही, this will complete the one octet state. Here also complete the octet state. This also complete the octet state. This also complete the octet state. And this also complete the octet state. Understand? But central atom, that is the phosphorus. And phosphorus will having how many electrons? Say 10. 5 plus 5, 10. So it cannot complete. Then also we can say it is a stable. So this is the limitation of Lewis approach. Then we can also say the next point, that here with the stability is decreased with increase in the atomic size. Stability is decreased with increase in the atomic size. Right? If the atomic size will be what? Increase, then the stability will be decrease of central atom. Right? As for example, just like a NH3, then it comes PH3, ASH3, SBH3 and BIH3. So this is the order of stability. Understand? So all these things you have to know. Right? Now, today we are going to discuss about the types of covalent bond. Basically, there are three different types of covalent bond is there. One is a polar covalent bond, second one is a non-polar covalent bond, and third one is a coordinate covalent bond. So let us start. First one, that is the polar covalent bond. Say types of covalent bond. Types of covalent bond. That is, first one we can say polar covalent bond. Polar covalent bond. Now, what do you understand about the polar covalent bond? We can say that in the polar covalent bond, here atom of element having a different electropositivity or electronegativity can share the one electron, and whatever the bond it can form, that bond is said to be the polar. Right? So I can write down atom of an element, atom of an elements, right, having different electropositivity or having different electropositivity or electronegativity takes a part in the formation of covalent bond. Takes a part in the formation of covalent bond is called polar covalent bond. Understand? That this indicates that if there is a difference in the electronegativity between the two atoms, then whatever the bond it can form, that bond is said to be the polar. As for example, see here, just like a H and Cl, 1, 2, 3, 4, 5, 6 and 7. So in between this, whatever the bond it can form, that bond is said to be the polar. Why? Because H and Cl, this carries a partial positive charge and this carries a partial negative. Why? Because chlorine is more electronegative as compared to that of hydrogen. Right? So whatever the bond is said to be the polar. Understand? Then second one, that you can say non-polar covalent bond. Now, what do you understand about the non-polar? We can say when a covalent bond is formed by sharing of electron and of atom of same element, then the bond is said to be the non-polar covalent bond. When a covalent bond is formed by sharing the electron of a same atom, by sharing the electron of an atom, by sharing the electron of atom of the same element, then the bond is called non-polar covalent bond. Then the bond is called what? Non-polar covalent bond. Right? Means same electronegativity. As for example, just like a H2, that is H, here also H. Same electronegativity is there. So this whatever the bond it can form, that we can say is a non-polar. Why? Because there is no difference is there between the electronegativity of two atoms, right? Same way, just like if I take O2, so oxygen and oxygen. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. See here, here also, and here oxygen, double bond, oxygen. 3, 4, 3, 4. Understand? Is it clear? So this we can say is a non-polar covalent bond. Covalent means sharing of two electrons is there, but it is not a polar, right? So that we can say it is a non-polar covalent bond. Now third one, that is a coordinate covalent bond. Let us see. Coordinate covalent bond. Now, what do you understand about the coordinate covalence? See here, that only one atom can share the two electrons and forms a bond. No, so that bond is said to be the coordinate covalent bond. So that things we have to know. That let us suppose here the electron pair is donated by atom of only one, right, from two elements. Okay, the bond is formed. Bond is formed by donating the electron of only one atom. The bond is formed by donating the electron of only one atom, right, from two elements. From two elements, that is called the coordinate covalent bond. As for example, if I take one example, just like a NF3, BF3 and NH3. If I write here BF3 and here NH3, in between that is a coordinate covalent bond is there. यहाँ पे देखो बोरॉन के आउटर मोस्ट ऑर्बिट में 3 इलेक्ट्रॉन, सो 1 2 एंड 3. तो यहाँ पे कौन आएगा? फ्लोरीन. यहाँ पे भी फ्लोरीन और यहाँ पे भी फ्लोरीन. अंडरस्टैंड? और नाइट्रोजन की आउटर मोस्ट ऑर्बिट में 5 इलेक्ट्रॉन है, तो यहाँ पे हाइड्रोजन 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 एंड 2 इलेक्ट्रॉन इज अ नॉन बॉन्डिंग, राइट? नाउ ये नाइट्रोजन क्या करेगा? कि इलेक्ट्रॉन डोनेट करेगा. किसको डोनेट करेगा? बोरॉन को. क्यों? क्योंकि एक ही एटम से जो इलेक्ट्रॉन पेयर डोनेट करता है और उसके बीच में जो बॉन्ड बनता है उसको हम क्या बोलते हैं? कोऑर्डिनेट कोवैलेंट बॉन्ड. तो ये नॉन बॉन्डिंग इलेक्ट्रॉन पेयर है, तो ये एक इलेक्ट्रॉन डोनेट किया किसको? बोरॉन को. एंड व्हाटएवर द बॉन्ड इट कैन फॉर्म, दैट बॉन्ड इज सेड टू बी द कोऑर्डिनेट कोवैलेंट बॉन्ड. यहाँ ये साइन है, ये दिस इज द डोनर एंड दिस इज द एक्सेप्टर, राइट? नाइट्रोजन ने इलेक्ट्रॉन डोनेट किया और बोरॉन ने इलेक्ट्रॉन गेन किया, राइट? एंड व्हाटएवर द बॉन्ड इट कैन फॉर्म, दैट बॉन्ड इज सेड टू बी द कोऑर्डिनेट कोवैलेंट बॉन्ड, राइट? चलो राइट डाउन ऑल दिस थिंग्स. Next point. Next point it will be given, that is a bond length and bond angle. Let us see. What do you mean by bond length? Bond length. Yeah. We can say that the equilibrium distance between the nuclei of a two atom, equilibrium distance between the nuclei of a two atom combined with each other by a bond, that is called, in the molecules, that is called what? Bond length. Let us see that the equilibrium distance between the nuclei of two atom, the nuclei of two atom combined, here two atom combined by bond in the molecules, combined what? By bond in the molecules, by bond in the molecules, right? Is it clear? Is called bond length. Is called what? Bond length. Is it clear? And if you want to find out the bond length of between the two atoms which are present in the molecules, then you can find out with the help of X-ray diffraction as well as the spectroscopic method. So if you want to find out, the bond length is measured by the bond length is measured by what? X-ray diffraction and spectroscopic method. X-ray diffraction and spectroscopic method. Understand, madam? And it is a measured in picometer. So 1 picometer, that is equals to 10⁻⁻12 meter. See, bond length how you can measure? Just like the H2 molecules is there. So यहाँ पे ये एक हाइड्रोजन, ये दूसरा हाइड्रोजन, यहाँ पे न्यूक्लियस है, तो इन दोनों के बीच में जो डिस्टेंस है उसको हम क्या बोलते हैं? उसकी बॉन्ड लेंथ. ये हाइड्रोजन डैश हाइड्रोजन. इज इट क्लियर? तो कितनी है? तो ये डिस्टेंस आया 74 पिकोमीटर. नाउ लेट अस सपोज इफ आई राइट हियर F2, सो F डैश F है, तो यहाँ पे n इक्वल्स टू 1 और n इक्वल्स टू 2, यहाँ पे भी n इक्वल्स टू 1 और n इक्वल्स टू 2. तो डिस्टेंस यहाँ पे यहाँ के यहाँ का जो डिस्टेंस है, राइट, सो दैट वी कैन से दिस, वी कैन से इट इज 144 पिकोमीटर, राइट. सो दिस इज द बॉन्ड लेंथ. इज इट क्लियर? Note down all these things. Then after it comes what? So bond angle. Right. Now what do you mean by bond angle? Let us see. The angle between orbital possessing bonding electron pair. The angle between orbital possessing bonding electron pair, bonding electron pair, that is called what? Electron pair around the central atom, around the central atom is called what? Bond angle. उसको क्या बोलते हैं हम? Bond angle, right? तो ये बात आपको मालूम होना चाहिए. Around the central atom of molecules or ion. Molecules or ion. एक एग्जांपल लेते हैं. As for example, just like a H2O है water. तो ऑक्सीजन सेंट्रल एटम है. तो यहाँ पे नॉन बॉन्डिंग इलेक्ट्रॉन पेयर है. ये बॉन्डिंग इलेक्ट्रॉन पेयर. Orbital having a bonding, and here in between this, whatever the angle is there, this angle we can say 104 degree and 30 minutes, right? So this we can say is a bond angle. Is it clear? Bond angle means what? The angle between ऑर्बिटल वर्सेस बॉन्डिंग इलेक्ट्रॉन पेयर। सी यहाँ पे बॉन्डिंग इलेक्ट्रॉन पेयर है, उसके बीच में जो एंगल है तो उसको हम क्या बोलते हैं, बॉन्ड एंगल अराउंड द सेंट्रल एटम। ये सेंट्रल एटम के अराउंड है। इज इट क्लियर? Write down all these things. चलो next one. Next it will be given, that is a bond energy or bond enthalpy. Bond energy, or you can also say it as a bond enthalpy, right? First one we can say the energy required for breaking 1 mole of a bond in a 1 mole of gaseous substance, right? The energy required, right, for breaking 1 mole bond, for breaking 1 mole bond, right, in 1 mole gaseous substance, in 1 mole gaseous substance is called bond energy. Bond energy. Is it clear? इसको क्या बोलते हैं हम? Bond energy. और bond energy means if you want to break the bond, then whatever the amount of energy is required, no, so that is called the bond energy. As for example, अगर हम example लेते हैं कि हाइड्रोजन है तो bond energy H की bond energy कितनी है? तो यहाँ पे 435 point something 8 किलो जूल पर मोल। अगर मुझे ये H2 गैस है और इसको मुझे H गैस प्लस H गैस में कन्वर्ट करना है, तो बॉन्ड ब्रेक करना है, तो आई रिक्वायर हाउ मच एनर्जी? सो बॉन्ड एनर्जी इज बॉन्ड एंथैल्पी टू ब्रेक द बॉन्ड, व्हाटएवर द अमाउंट ऑफ एनर्जी इज रिक्वायर्ड, दैट इज कॉल्ड द बॉन्ड एंथैल्पी, किलो जूल पर मोल, राइट? नोट डाउन। If the molecules or ion is more stable, then we can say that the bond enthalpy will be very, very high. Why? Because if the stability is more, then you require the more amount of energy to break that particular bond, right? Then last one. Last one, it will be given what? So bond order. Bond order. First, the bond order means the number of bond between the atom present in the molecules. The number of bond between atom present in molecules is called bond order. Bond order. As for example, if there is a only by sharing one electron, if there is a single bond, then the bond order is 1. As for example, let us suppose H2 molecules is there, right? So here hydrogen and hydrogen sharing of one electron. So what is this H dash H? So here bond order, how much? Only 1, right? if O2 molecules is there, then sharing 2 electron. Okay, 1 2 3 4, 1 2 3 4, right? Double bond 4 3 4, 1 2 3 4. यहाँ पे why? Because two bond will be formed between the two atoms and two molecules. Means nitrogen 1 2 3 4 5, 1 2 3 4 5. यहाँ पे देखो, right? So nitrogen triple bond nitrogen. Is it clear? So 3. As with the increasing the bond order, we can say that as a result the bond length decrease, then the stability will be increased. Bond length with increasing the bond order, increasing the bond order, the stability will be increased, is increased. Bond length decrease and bond enthalpy is increased, and bond enthalpy is increased. Why? Because to break this bond you require the more amount of energy. मैंने क्या कहा कि जितना बॉन्ड ऑर्डर ज्यादा है ना उतनी बॉन्ड लेंथ कम होगी. अगर बॉन्ड लेंथ कम है तो उस बॉन्ड को ब्रेक करने के लिए मुझे मोर अमाउंट ऑफ एनर्जी रिक्वायर, राइट? सो इफ यू रिक्वायर द मोर अमाउंट ऑफ एनर्जी दैट मींस द स्टेबिलिटी विल बी मोर. उसकी स्टेबिलिटी भी कैसे होगी? मोर होगी, राइट? सो ऑल दिस थिंग्स यू हैव टू नो, राइट? इज इट क्लियर? एनी प्रॉब्लम? So today we have discussed about, first of all, that is the limitation of Lewis approach. Then we have also discussed that is the types of covalent bond, that is a polar, non-polar and coordinate. Then we have discussed about the bond length, then bond angle, and last one that is a bond order and bond enthalpy, right? So all these things you have to know very well. Okay, so in this video up to here it's enough. Tomorrow we are going to discuss about the bond hypercycle as well as the resonance structure, right? Okay, so up to here it's enough. Thank you very much.